Hey y'all, welcome back to my channel. Today I want to talk a little bit about going from a word equation to a balanced chemical equation.
Oh, okay.
And I'm going to be showing you how to predict products too, which is something you haven't seen yet in the GPB videos. But as sharp as you guys all are, I know that you can probably follow along and glean a few bits of information as I do this. And if you're having trouble going from a word equation to that skeleton equation, the unbalanced version, this should be of help to you as well.
Oh, okay.
So let's take a look at an example problem here. So I've got up on the board solutions of lead 2 nitrate and sodium chloride are mixed and a precipitate forms. So let's first break this down and think about what's going on. When it says solutions of, that means we have two ionic compounds dissolved in water. That means both the lead nitrate and the sodium chloride must be soluble. So when we dissolve it in the water, the ions have separated, and when we mix them, now the soup of ions can interact in new ways. The equation also tells us that a reaction has taken place because the formation of a solid in the form of a precipitate, which is really fancy chemistry speak for an insoluble compound forms a solid. That means a reaction has taken place and we formed a new compound. So let's take a look at our reactants. We have lead 2 nitrate. Now we know that lead is our metal ion. The Roman numeral 2 tells me the charge on lead is +2. Nitrate is a polyatomic ion, as you know, and nitrate's charge is -1. So think back to writing ionic compounds. We need to balance out those charges. So when we write the lead 2 nitrate, it'll look this way. Pb parentheses NO3 2. Because it's in solution, we can use the indicator aqueous to show that. So I write a little AQ next to it. It reacts with sodium chloride, a familiar compound. Sodium is the metal, it's +1. Chlorine is the nonmetal, it's -1. So to simply write the formula, we have NaCl. It's also in solution, so we can also use the little subscript AQ. Now, in writing an equation to show that the two compounds are interacting, the reacts with part, what we're going to do is simply use a little plus sign between them. Now, this is critical, and I saw this on a lot of your practice problems. Once these subscripts are set, the 2 and the 1s that are not written here, those are set now. That's the chemical formula. We can't manipulate those to balance our equation. We can only use coefficients moving forward. So now let's look at predicting the products. What's possible here? Well, once these react together, or they're mixed together, the lead and the sodium won't interact. Can you imagine why? They're both positive. They'll repel each other. The same is true for the chlorine ion and the nitrate ions. They won't interact either. They'll repel each other. So the only possible new combinations are the lead and the chlorine, and the sodium and the nitrate. This is called a double replacement reaction, and we're just going to switch out the metals. We draw an arrow to separate the reactants from the products. And our new products, we have to write new balanced chemical equations for. Sodium is +1, nitrate is -1. So my reactants are sodium nitrate, NaNO3, and the lead will maintain its +2 charge, so lead is +2, chlorine is -1. So the other compound that forms is lead 2 chloride, PbCl2. So now we have our products as well, the reactants, the products, and notice the products are separated by that same familiar plus sign. The tricky bit for you is going to be to determine which one of these is the solid. You can look up solubility rules. If you simply Google it, there'll be a wealth of information for you. And a solubility table is fairly easy to decipher. One thing I know is that all nitrate containing compounds are always soluble. So I know that sodium nitrate will be aqueous. It will remain in solution. We use that AQ again. And the solid product that forms is the lead chloride. So this is what's driving our reaction forward. And you have actually seen this very reaction in lab. We did it in one of our first physical chemical changes lab. It's one that made that weird white solid when you mix the two clear solutions together. So now we have our skeleton equation. Let's balance it. I see I have one lead on the reactant side, one lead on the product side. The lead is okay for now. I have 2 nitrate. Now let's check, did the nitrate get broken apart by the reaction? No, it did not. So we can treat it as an entity and make our lives a lot easier for balancing. So I have 2 total nitrate over here, 1 nitrate over here. So I can use a coefficient of 2 in front of this to make there be 2 nitrate on this side. Remember, I cannot change the subscripts at this point. Those formulas are set by their charges, but what I can do is just increase the number of product particles that I make. Now, this has also changed the sodium. Now there are 2 sodium that appear on the product side. We can't create atoms from nothing, so that means there must have been more ingredients here. So if I put a 2 on the reactant side as well, now I have 2 sodium. Now again, I've changed the chlorine, but if we look, that matches up with the coefficient we needed in the first place to balance the +2 charge on the lead. So now we've gone from a word equation to, at first, a skeleton equation. We even wrote the states of matter, and we went through and balanced. So hopefully this is a little bit helpful to you. Please continue submitting questions to me. I'll try to make some short video clips moving forward, and I purchased a surprise for y'all. So stay tuned next time, and we'll be shifting our classroom outside. See you next time.